Let's talk about the Pythagorean Theorem. Now, how do you spell that? Pythagorean's Theorem. What is this? What is the Pythagorean's Theorem? Well, it's that thing you hear people say all the time. A squared plus b squared equals c squared. You've probably heard this repeated to you time after time. But what does it mean? Well, what it's referring to is a method that we can use to solve for the length of any side in a right-angled triangle if we know the other two sides. For example, if this here is length A and this here is length B, then this side here is length C. Now, A and B can switch, that could be B, that could be A, but this side here always has to be C. What do I mean by this side? I mean the side that's across from the 90-degree angle. So if you have a 90-degree angle here, the side across from it, the side opposite from that, is your C. Okay? And that side has a special name. It's called the hypotenuse. The hypotenuse is always the side across from your 90 degrees. It's also the longest side in a right-angled triangle. And that's important, otherwise this equation won't work, right? So that has to be C. Now what does this mean? How do we know that a squared plus b squared is c squared? Let's do an example, and I'll walk you through it, and you let me know if this makes sense. So let's say you have a triangle like this. It's a right-angled triangle. This side has a length of 4. This side here has a length of 3. And this long side here, you see, has a length of 5. So your base here is a length 4, right? That's your b value. This here, according to the equation, 3 squared plus 4 squared equals 5 squared. Or it should, right? 3 squared plus 4 squared should equal 5 squared. And it does, right? Because 3 squared is 9, 4 squared is 16, 5 squared is 25. You get 25 equals 25. So obviously this equation works, right? A squared plus b squared equals c squared. This equation is true. But why does it work, right? How does it work? Why does this make sense? Well, if you think about it, when I say 3 squared, that means you have a square with a length of 3. So like if this length is 3, and you made it into a square that was 3 by 3, how would this look? Well, it's a square with dimensions of 3 in each direction. So 3 blocks by 3 blocks, that gets you 1, 2, 3, 4, 5, 6, 7, 8, 9 blocks. So the area of this whole thing is 9. What about the 4? Well, it's the same idea, right? If you draw a square like this, that's 4 by 4. So that side squared, literally we're squaring the side, we're turning it into a square, and you split it up into your blocks 4 by 4, like that, and also this way. How many blocks do you have here? 4 times 4 is 16. If you count them up, you also get 16 blocks. Now remember, a squared plus b squared should equal c squared. So the amount of blocks I have here should be the same as those two added up. So if you do 1, 2, 3, 4, 5 blocks in length by 1, 2, 3, 4, 5, kind of squished here, but 5 by length, right? So that's 5. This is 5. 5 times 5 is 25. If you add them all up, you get to 25. So if you say, all of these here, you shade in 1, 2, 3, 4, 5, 6, 7, 8, 9. If you look here, they're all accounted for. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then these ones here, put a line through each one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Same thing here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. They're all accounted for. So this square up here is made up of all the squares from this square and this square. So it works out quite nicely. This is the visualization, I guess you could say, of the Pythagorean theorem. And what the takeaway should be is that whenever you have a right angle triangle, you can use this equation or this theorem to figure out the length of a missing side. So, for example, if you have something like this, where that's 90 degrees, and there has to be a 90-degree angle for this to work, and you say this side is 6, and this side is 3, and this side is C, and you're told find C, you say, okay, 3 squared plus 6 squared equals C squared, right? A squared plus B squared is C squared, same idea. So you get 9 plus 36 equals C squared, so 45 equals C squared. To solve for C, you have to square root both sides, so you get square root of 45 is equal to C. So that's the exact answer. If you want to round it, you can get 6.71 approximately is equal to C. Just like that. So that length is approximately 6.71. So if you were to use your ruler on a piece of paper and you draw a line that's 3 centimeters long and then at 90 degrees you draw another line that's 6 centimeters long, and then you connect those two lines together, and you measure that line. It'll be approximately 6.71 if you try to measure it. And what's nice is you can also use this theorem to find the other sides. Like let's say I have a triangle like this. Again, another 90-degree angle. This is 4, this is x, and this is 7. How do I solve for x? Well, again, it's a squared plus b squared equals c squared. I can make 4 my a, so like 4 squared, plus b will be x, so x squared equals c squared, that's 7 squared. So now I gotta bring my 4 squared to the other side, so x squared equals 7 squared minus 4 squared. So x squared is equal to 7 squared is 49, minus 4 squared is 16. X squared is equal to 49 minus 16 is 33. And so now your x is equal to the square root of 33. You square root both sides, right? And the square root of 33 is approximately equal to 5.74.